cart ride is the Ferris wheel. One Ferris wheel has a diameter of 50 feet. Riders board the cars at the ground level, okay, and then it moves counterclockwise. Each ride consists of 4 revolutions, and you can assume that the Ferris wheel rotates at a constant rate. So we're going to create a sketch of the height of a rider above ground with respect to the number of revolutions. 4 revolutions. Okay, so how many of you ride the Ferris wheel? I hate it. You hate it? Yeah, I didn't care. I don't care much. So a Ferris wheel goes like this, right? Well, this is counterclockwise for me, but not for you. Anyway, so when I graph this, am I going to graph it like this? Why not? You said no. Why not? Okay, so can I graph it like if I'm on the Ferris wheel? Is that going to be my graph? No. Why not? Yeah. Well, even so, like if this is revolution or if this is time, what's happening right here? It's going back in time. Yeah. It's not the DeLorean. It's a Ferris wheel. Okay. Yeah. So that's not what it's going to look like. We can't travel back in time. Alright? So here's what we're going to do. Let's just plot a few points. If we just got on the Ferris wheel and it hasn't started yet, our revolutions are 0, and our height is 0. And then what happens halfway between no revolutions and 1 revolution? If it's at a constant rate, how tall do we get on that Ferris wheel? On this particular Ferris wheel? 50 feet. How do you know you're 50 feet in the air? The diameter is 50 feet. That's the diameter of the Ferris wheel. So if 1 whole revolution brings us back to the bottom, halfway through we're at the top, and we're at 50 feet. Gee, thanks for giving us 5. Alright, and then 1 revolution, we're back down here. And then again, it's going to be up here. So if we were to graph it, it actually looks like that's the graph of our path on the Ferris wheel. Right? Okay. Alright, what do you notice about this graph? This is question 3 on 963. What are just some things that you notice? What are some characteristics about this graph? You notice nothing? What do you mean it's the same? If I cut it up every time we hit the ground, if we started over, would it be any different? No. Good. It's because it's a periodic function. It is a periodic function. And a periodic function means that all the values repeat over regular intervals. You can cut it and move it, and it's exactly the same. That's a periodic function. It repeats itself, okay? It's continuous. You can trace it without picking up your pencil, which is good if you think about a Ferris wheel. Like, you don't want to be at 50 feet and then jump over to 40. That's bad. You want to, that's impossible, actually. So, anyway, it's continuous, periodic. Let's see. What's the maximum? 50. What's the minimum? 0. Okay. How many zeros do we have on this one? 4. How often do they happen? Yeah, every single whole number is a 0, right? If we stayed on it forever, how many zeros would we have? Forever, it'd be infinite. You always would go back down on the Ferris wheel. Right. Okay? Great. For each rotation, the graph is exactly the same. Alright, so let's look at this next Ferris wheel. Right here, this one. At a different amusement park, a Ferris wheel was designed so that half the Ferris wheel is actually below the ground. The diameter of this underground Ferris wheel is still 50 feet. So the top reaches 25 feet above ground and the bottom reaches 25 feet below ground. Riders board the cars at ground level to the right, and the Ferris wheel moves counterclockwise. So create a sketch to model the height of the rider and do 4 revolutions. Alright, so I'm going to let you try this one on your own for about a minute, and then we'll graph it together. So this one's a little bit different. We still board on the ground, but how high do we get? 25. Our maximum is going to be 25. What's our minimum going to be this time? Negative 25, because you're going 25 feet below ground. Cannot imagine the appeal of a ride like this at all. Right? So, whatever. Alright, so I'm going to give you about a minute. Alright, so I am going to put 0 right here in the middle. Where are my axes? These are revolutions. And this is height. So this is 25. And that's negative 25. Awesome. Okay, so it starts out, I'm right here. That's where I am. Now, this is a little bit different because when I make one revolution, one whole revolution, where am I going to be back at? I'm going to be back at 0, right? So what has had to happen from here to here? It had to go up and back down. Okay, so let's see. That's going to be right there. If I get on it right here, here I am getting on it, and it goes counterclockwise. No, it's going to go up. Yeah. So then that's going to happen again. What is counterclockwise? Counterclockwise. Hang on. Does it say it's going counterclockwise first of all? Oh, but it said on the right. It said on the right. So here's the Ferris wheel. So yeah, that would be a horrible Ferris wheel. Don't get on one foot like that. That is not safe. I don't care what any person, what any carny tells you, no matter how many teeth he has. Don't get on that. Yeah, I forgot. Yeah, it says to the right. Yeah, I knew it went up first. I just couldn't remember why. Got that one. In here. In here. So this one's gonna go something too big. Like this. Alright, is this still a periodic function? Yeah, I could pick this part up, especially if I throw it meter. But I could pick up from here to here And it would just be exactly the same all the way across. It's still a periodic function. What is the period of this function? How long does it take to start repeating itself? One revolution. Right, that's the period of the function. Okay? Good. Alright, look at problem 3 on page 966. Alright, so this is going to a lot of definitions here, and then we have to draw some stuff. But in the last two problems, you looked at the height of a rider above ground as a function of the number of revolutions. You can also use angle measures. Alright, so standard position. An angle is in standard position when the vertex is at the origin and one ray is the x-axis. Okay? That ray that's the x-axis is called the initial ray, and the other one is the terminal ray. So it's like you're on a circle and the circle's opening up. The one that moves is the terminal. That's telling you where to stop. Stop here. The one that stays on the x-axis, that's telling you where to begin. That's your initial ray. Start here, stop here. Okay? So, initial ray, terminal ray. You want to see how that works? Alright. Then the measure of an angle in standard position is the amount of rotation from the initial to the terminal ray. When the rotation is counterclockwise, the angle measure is positive, and if it's clockwise, it's negative. And you can line these up and graph on a piece of paper, which is exactly what this is, but it's really not going to work here. But what you can do, you have a straight edge, and you have something to measure, like 90 degrees is right here, so you would go to 90 and that height. 180 is right here, so 180 is going to be at 0. 270 is back down here, so 270 is going to be down here at negative 20. And you can go through the whole circle, and what you'll find out, 0 is at 0, 90, is back at 0. What you'll find out is you get the same thing over and over again. Graph points. You get a periodic function. Now, what's the period of this function? How long does it take before it's exactly in the same spot, start all over again? Which is it, 180 or 360? It's 360, because if you'll see, I start at 0 going up, and it's back at 360 again before I'm at 0 going up. 180 does go to 0, but is that exactly the same? No, at 180 it's going down, and I need to be going up. Alright. Alright. Amplitude. Amplitude is how wide, how tall a graph is. And amplitude is 1/2 of the absolute value of the difference between the maximum and the minimum. So This difference is 40. Half of 40 is 20. This one has an amplitude of 20. If it went to the other one that went to, bless you, to negative 25 and 25, what was that amplitude? 25. Yeah, they're easy when they're at 0. When the midline is 0, it's really easy to find the amplitude. And midline is the line that goes right down the middle of the function. Now that first problem we had, that didn't have a midline of 0. The very first Ferris wheel that we did, that went all the way up to 50 and started at 0 and it didn't go underground because it wasn't sick and twisted. It went up to 50. What was the midline on that one? What line would have been right in the middle of that? 25. Yeah. 25 would have been the midline. Exactly. Alright, so those are, now you're like, what does this have to do with trig? Well, sine and cosine are periodic functions. They repeat themselves. We're going to talk about their amplitude. We're going to graph them. Remember last year we did sine and cosine and tangent, and it was all about the triangle? Well, this year it's going to all be about this unit circle. We're going to talk about some triangles, but it's mostly going to be focusing on this circle. But right now we're just going to look at more graphs. Look at your skills practice that you poured out.